My name is Dan Blondal, and I am the CEO of Nano One Materials. We are a Canadian company headquartered in Vancouver, Canada, with production facilities developing in Montreal in the eastern side of Canada. I'll go into that in more detail. Essentially, we are developing process technology to improve the way cathode materials are made. We're driving down cost, complexity, environmental footprint, waste streams in the manufacturing of cathode materials. It is a platform technology we call the one-pot process, and it enables us to make LFP, NMC, manganese-rich materials, virtually any type of cathode material, and it enables us to use alternative sources of the raw materials, lithium, nickel, manganese, and cobalt, to drive down the cost and complexity in the process. So that's a very quick summary. We are a publicly traded company on the TSX in Canada, so this is just our standard disclaimer that I will say things that you shouldn't use for investment advice. I'd like to just start first of all by thanking the Japan Battery Association and supply chain that came to visit our facility in March of this year. After PDAC, we had a contingent there of 20 or 25 delegates from the Japanese community at our facility just outside of Montreal, where we were able to discuss some of the Japanese motivations to get to 150, 200, 300, 400 gigawatt hours in the next few decades, and what that means for Japan, what that means for Canada, what that means for global collaboration, and what it's going to take to get to net zero in the next 10, 20, 30 years. It will need innovation, it will need collaboration between nations, between companies, between different parts of the supply chain. The facility we have it's in Candiac, Quebec. That's about 20 kilometers outside of Montreal. It is an existing battery, lithium iron phosphate battery cathode manufacturing facility that we acquired from Johnson Matthey last year, and it is our center for operational excellence, and we are converting it to our one-pot process for more sustainable manufacturing of LFP materials and to prove the scalability for much wider expansion of the technology. We have a flexible business model for the manufacturing of cathode materials, be it nickel, iron, or manganese-based. We believe that independent manufacturing is going to be important in our early stage, but really the big growth will come through joint venture and licensing of our technology to various partners, and I'll walk you through that in more detail. But first of all, let's take a step back just to look at the supply chain. You've seen many graphics like this today and over the last few years showing the circular economy. Batteries are synonymous with electric vehicles. They really came into first commercial production here in Japan in the early 1990s with Sony. And at the time, there always has been a lot of waste water, waste energy, waste greenhouse gases that are associated with the various processes in the supply chain. However, the volumes have been relatively low and of minimal concern. As we move into net zero, as we move into the terawatt-hour world, we must find ways to eliminate these sources of waste and these streams of waste. And that's what I'm going to walk you through. And this is where Nano One's technology, the one-pot process, really brings about change. We must think like the fossil fuel industry. To date, most cathode manufacturing has been small companies growing into much larger companies, but we have to start thinking more uniformly across the whole supply chain. How do we clean this up? How do we make it more energy efficient? How do we eliminate the waste? How do we get rid of all the water usage that's associated in the supply chain? And so it's going to require innovation. It's going to require collaboration. We fit in the cathode space, making cathode materials. We do neither PCAM or CAM. We do it together. We basically have no PCAM in our process. We go direct from the raw materials into a cathode material. We've developed partnerships with BASF and Umicore in the midstream to use our technology to make their materials. We announced a partnership with Our Next Energy, who you heard from earlier today, to develop an LFP supply chain for input into their LFP batteries. The Canadian government has been very supportive of Nano One over the years and continues to be, obviously within Canada, but also in Japan and other jurisdictions. Last year, we had a partnership. We announced a partnership with Rio Tinto, where they invested $10 million US in the company. That amounts to just under 5% of ownership stake in Nano One, and we are developing supply chains for iron and lithium into our LFP product line. And I'll speak to that in a little bit more detail. We also work with a number of other players up and down the supply chain. CBMM from a niobium front, that's for coating our nickel and manganese-based materials, and also with a number of junior mining companies. And then lastly, really all the way down the supply chain with the OEMs. We have an announced partnership with Volkswagen, and we have a number of undisclosed partnerships with other automotive OEMs where we're developing all three of our technologies, LFP, NMC, and manganese-rich materials for applications obviously on the automotive stream. So this is an aerial view of the plant in Candiac that we acquired from Johnson Matthey. That's the pack of land that we acquired. It's just over kind of 8 acres in land. It has been in operation as an LFP plant since 2012. However, there were some economic challenges in scaling the technology that was used there. But the technology, the equipment in that plant was uniquely suitable to the one-pot process. And when we purchased the plant, we shut it down. We're retooling it, we're recommissioning it, and we're just bringing it back up to pilot capability. It'll be done, the first pilot runs will be done at the end of this quarter, and by the end of this year, we will have pilot capability anywhere between 200 to, in basically a 1-ton type of samples, but really emulating a 2,000-ton plant. It came with 45 people, probably the most experienced LFP producers and cathode production people in North America today, because it is one of the only operating cathode plants today in North America, and they've been working there for 10 years. We are, as I said, we've been doing trials, piloting, validating our materials with our partners, qualifying them for offtake. This will be the launch pad for commercialization and production of cathode materials. There's space in the land to scale up to, we believe, up to about 25,000 tons, and engineering plans are underway right now to put that plant in place. This is a picture of really the key part of the process, the one-pot reaction. That's where the lithium and the iron and the phosphorus all go, and the carbon coating all go into one reactor. And we have really 2 scales that we've put in place. The existing reactors allow us to go up to 2,000 tons. And we put new reactors that allow us to pilot on a smaller, sort of more practical scale, allows us to test and validate in a faster time frame. But this really allows us, we've been able to do repeat trials up in the large reactors, demonstrating that full-scale reactors work with the one-pot process. We believe we've completely de-risked scale up for full production. A larger factory would simply have more of these reactors. They don't get any larger than the ones we currently have in place. So we're quite confident that the technology is de-risked, and we're moving forward with our automotive partners and our energy storage partners to validate these materials for offtake, and that'll all be happening, starting to happen this year. So you might be asking, why bother changing what is already working? Obviously, there's a lot of LFP batteries out there, mostly in China. There's a lot of NMC batteries out there being deployed around the world. So what is it we're trying to change? The lithium-ion battery supply chain, the cathode supply chain, is long and complex. There's a lot of steps from mining to refining to cathode materials, all the way through to the PCAM and the CAM and the coating processes. Before you get to recycling the battery, where the battery is crushed and shredded, ultimately back to a black mass, which then has to be reintegrated into the system. All along the way, what happens is it's kind of long, it's complex, and actually it's quite wasteful, and I'll walk you through that. Really, the first big challenge is sodium sulfate. Sodium sulfate is used in refining, it's used in mining, it's used in the PCAM process today. It's used in LFP, and it's used also in NMC. And the issue is that that sulfate is used to dissolve the materials, get everything mixed in together, and then it comes out as a waste stream. The amount of sodium sulfate that is produced in LFP or in NMC is anywhere from 1 to 5 times the product stream. So it's a very large amount of byproduct. And it's very difficult to allocate that sodium sulfate into other markets because those markets quickly become saturated. Disposal is not really an option in very large volumes, and recycling it is very energy and CapEx intensive. So I'll explain how we resolve that problem, but before we do that, I want to just walk you through the next step in the process, which is the kiln. So once you've made your PCAM, you mix it with lithium, and you put it in a kiln. Those kilns are big, long roller hearth kilns. You put the materials in the trays that you see here in the nice picture, and they're pushed down these kilns that are maybe 50, 60, 70 meters long, sometimes stacked 2 high, 4 wide, and they can take up to a day to get through the kiln. The material comes out. It often is melted into a big block. It has to be crushed, ground, milled, and put through the kiln again. Very energy intensive. You're having to heat those trays up every time they go through the kiln rather than just heating up the materials, so there is a lot of waste energy that goes into making these materials. However, this is the way cathode materials are made today, and there is a fair amount of reluctance to change this because it works. Each one of these roller hearth kilns will produce anywhere from 1,000 to 2,000 tons a year. So once you start getting into a plant that is making 50, 60, 100,000 tons a year, you need literally 50 or 100 of these things, and each one of them taking up half a football field. So a fairly big physical footprint on these kilns. So we believe that in the long run, this isn't scalable when we start to have to get into the tens of millions of tons of materials worldwide. And then lastly, the coating step is really key to cathode materials. For LFP, you coat with carbon in order to make it conductive. For NMC materials, you coat with titanium or niobium to protect the nickel and manganese from dissolution during charge and discharge. However, those things can crack over time, and I'll explain how we resolve that. So we see these 3 problems as really being the fundamental issues to solve in cathode production. How do we resolve it? How do we make them less expensive? How do we do it more effectively? How do we improve the environment? We kind of turn it all on its ear. And I'm going to step you through these each step. First of all, on the sulfate front, we go directly, our one-pot process goes directly from metallic nickel or metallic iron or metallic manganese. We can go from hydroxides, we can go from carbonates, but we've completely eliminated the need to go through a sulfate. That means there's no water wastage from all the rinsing, and there is no sulfate coming out of it. So we have 0 waste stream in the one-pot process. And ideally in recycling, when you bring the black mass through and you can actually go directly back into the one-pot process without going through an intermediate sulfate. That early stage recycling, the recycling is in early stage development at Nano One today. On the LFP front, I want to just kind of bring this up. This relates back to our relationship with Rio Tinto. Rio Tinto and Nano One really came together on this vision of using iron metal powder out of their factory in Canada, where they make 180,000 tons right now of Class 1 automotive grade, IATF certified metal powder that can be used directly in the one-pot process, eliminating the need to go through sulfates, eliminating the waste streams that are associated with any kind of refining of those materials, and it's all done under hydroelectric power. So it is a very sort of clean process. Once we make that PCAM, it's already got lithium in it. We don't mix it in later. And so it's already chemically reacting, it's already forming the crystals. It means it actually forms the cathode materials very rapidly in the furnace. And that allows us to go through a thermal process that's literally measured in hours instead of days. It means we don't have to go through roller hearth kilns. We can consider going through alternative furnaces like a rotary kiln, which have a much smaller footprint. There's no containers to heat up, and it's much more energy efficient. And then lastly, we are able to coat the materials. All the coating agents go in with the lithium and the dopants and everything else in the one pot, and then they segregate out during the final thermal process to coat the cathodes. Same way it happens with LFP, we coat with carbon, and with our nickel and manganese-based cathode materials, we're coating with niobium, which actually coats the single crystal as the materials on the nickel and cobalt-based materials expand and contract. They tend to fall apart, and it leaves the single crystals protected from deleterious reactions, so you're able to extend the life of the battery material itself. And that kind of brings me mostly to the end of my presentation. What we have here, we believe, is particularly with LFP, is probably the cleanest, fastest, lowest cost way to make cathode materials, and with 100% sort of secure and reliable CAM and supply chains that are not necessarily reliant on the existing LFP market in China. So a very important part to what we're doing, obviously, in North America and obviously in Europe, and we believe it's going to be important in the Indo-Pacific region as well. So thank you very much for your time. I believe according to the clock, I have 4 minutes of questions. I know we're operating this a little differently than this morning, so we're not. So please, if you have questions, fire them our way. Robert might have some already online for me.
We do. Thank you, and thank you, Dan. Cheers. Yeah, thanks for that, Dan. And I'd just like to remind you, if you do want to ask a question, put your hand up or just fill in the app or QR code. We've got a couple of questions here, Dan. Obviously, we're in the Asia Pacific, the home of cathode production today. What can producers looking to develop scale in North America, Europe, other regions, what can they learn from the Asia Pacific region?
There's a tremendous amount to learn from here. Look, I think one of the biggest obstacles to expansion is what we would call the learning curve. It's the know-how. How do you produce these materials with as minimal waste as possible? How do you do it with as high a yield as possible? Anytime you tip up a battery factory, there's a tremendous amount of waste. Getting it to 10% sort of waste or 90% utility is actually one of the biggest challenges. The same thing happens in cathode. There is a tremendous amount of waste that goes in there. So you reduce that, you get to full-scale production, you get your yields up with experience, and that obviously exists in spades here in Japan. And in North America, there's precious little of it. That's why I think we look to partner with Japanese companies and with the Asian Pacific companies to really help accelerate the adoption of these materials in North America, because that to me is one of the most important things, and it's almost always overlooked until it's too late. We recognize it was really important. The acquisition of the plant in Candiac in Montreal gave us access to 50 people, albeit very small in the Asia Pacific context. It's a very large team in the context of North America, and that will be our training ground for expansion. So we will funnel people through there, train them up to become the experts we need to maximize yield and improve the efficiency of the process.
Excellent, thank you. Just sort of on the point of developing the expertise in North America, what do you see as the main challenges from your perspective in developing that?
In developing the expertise?
Yeah, or bringing it over, or finding the people that you need.
Well, I think there are a number of big challenges in bringing Asian manufacturing expertise to North America, and I think some of them actually relate to even the sodium sulfate I was talking about. There is a reluctance to come into North America with the permitting restrictions that are there that don't necessarily exist in China, Japan, and Korea. And so it's hard to bring that expertise over because people don't want to operate under the stricter permitting conditions. So again, we believe by eliminating the need to permit for sodium sulfate, we can actually accelerate the adoption of that. So that's kind of one instance. Obviously the investment that's required is really important. And when you're competing against let's say, all the infrastructure that already exists in Korea and Japan and China, that's already paid for, that's already, all that CapEx is already paid for, to tip that up and do it in North America, it's very expensive. So it requires support, not only from the industry, the OEMs, the integrated miners, but obviously the governments as well. So that's going to be, it's going to be extremely important to building the infrastructure, the talent, and to be able to attract the talent that we're talking about.
Excellent. Thank you very much, Dan. And I think we're pretty much up for time, unless anyone else has a question. Okay. Well, thanks, Dan.
Thank you, Robert. Much appreciated.
Take care.